James Webb Space Telescope detects mysterious lights near Proxima Centauri b. Could be alien life? The James Webb Space Telescope, JWST, has made a jaw-dropping discovery. Beams of light coming from what appears to be a highly active region, possibly resembling a bustling city, about 4 light-years away. This unexpected finding has reignited the age-old question. Are we alone in the universe? JWST focused its powerful infrared vision on Proxima Centauri b, the closest known exoplanet outside our solar system. What it picked up was strange, bright, flashing light patterns that scientists can't yet explain. Could these be signs of intelligent life? The scientific community is abuzz, and investigations are ongoing. Human fascination with alien life is nothing new. But now, thanks to JWST, we might be looking at the first real evidence, not just speculation. During a detailed scan, the telescope picked up light emissions that resemble artificial city lights, raising hopes that intelligent beings might exist out there, possibly running entire civilizations we can barely imagine. This discovery has astonished NASA engineers, especially given that these lights may have been shining for years, just waiting for us to develop the technology to finally see them. David Kipping, an astronomer at Columbia University, points out that Proxima Centauri b is an unusual planet. Unlike most rocky worlds, which absorb sunlight and re-emit it as infrared radiation, this planet shows an odd interaction with its parent star, Proxima Centauri. The telescope's ability to detect infrared light played a crucial role here. It allowed researchers to study how the planet reacts to heat and light, offering new insights into its atmosphere. The light signals might be more than a cosmic coincidence. They could be a sign that Proxima b is home to complex processes, maybe even life. Proxima Centauri b orbits its star in just 11.2 Earth days and experiences intense temperature swings. These shifts could be extreme, scorching hot on one side and freezing cold on the other, especially if the planet lacks a substantial atmosphere. This contrast is significant because it provides clues about whether the planet could support life. JWST's infrared capabilities are perfect for observing these temperature patterns and analyzing atmospheric data. Its sensitivity allows it to detect faint light sources, like potential artificial illumination, on the planet's dark side. That's why this telescope is ideal for identifying possible alien city lights, especially if they fall within a specific wavelength range. While JWST is a powerful tool, it can't do it all. For even more detailed atmospheric analysis, scientists are looking forward to ground-based observatories like the extremely large telescope JWST, which is expected to begin operations in 2028. The JWST will be capable of zooming in on distant exoplanets and examining their atmospheric composition in even greater detail. Future space missions may bring even more advanced tools. To better observe exoplanets, scientists are developing new methods to block starlight that usually overwhelms the faint glow of planets. Tools like coronagraphs, which reduce starlight to reveal the planets orbiting nearby, and Starshade's large, flower-shaped devices that block starlight before it hits a telescope, are among the most promising innovations. These technologies must be highly precise, energy-efficient, and capable of functioning flawlessly in space. Despite the engineering challenges, the payoff could be enormous. These innovations could let us detect key biosignatures in exoplanet atmospheres, such as oxygen, methane, and water vapor, which are strong indicators of life. Even now, JWST is helping us peer into the past. Since light from these planets takes years to reach us, we're essentially seeing snapshots of ancient cosmic history. Every new discovery brings us closer to answering one of humanity's biggest questions. Is there life beyond Earth? This possible detection of artificial lights on Proxima Centauri b is just the beginning. It signals a new era in space exploration. As JWST continues its mission, scientists will study exoplanet atmospheres, surface conditions, and light patterns, searching for anything that could indicate life. While JWST isn't optimized to detect free oxygen, a critical marker for life, it can identify other potential biosignatures like ozone, carbon dioxide, and methane. These findings could be the stepping stones to deeper discoveries about the potential for life on other worlds. Looking ahead, scientists aim to not only detect distant exoplanets, but to take detailed images and even study their weather systems. With tools to block out starlight and improve image clarity, future telescopes could help map alien worlds in ways that were once the realm of science fiction. In the end, the discovery at Proxima Centauri could be a historic moment, the first flicker of light in our quest to find life elsewhere. Whether these signals turn out to be artificial or natural, they push us to look further, ask harder questions, and dream bigger. The James Webb Space Telescope, JWST, can detect infrared light, allowing it to observe planetary activity, even on the night side. Most telescopes can't detect such faint light from distant planets, but Webb excels at picking up even the smallest signals. That makes it ideal for verifying whether the dark side of Proxima Centauri b is lit by artificial lights, potential signs of civilization. Webb can detect artificial light if it falls within a certain infrared range, which is narrower than the broader light spectrum emitted by stars. Proxima Centauri b has a complex relationship with its star, receiving intense energy that causes extreme temperature swings. Like Earth, it experiences day and night as it orbits its star, but the surface can become scorching during the day and freeze at night. This extreme contrast largely depends on whether the planet has an atmosphere. Without one side would be blistering while the other remains frozen. These temperature shifts are crucial clues for astronomers, helping them determine whether the planet has an atmosphere and what it's made of. Thanks to its infrared capabilities, JWST is perfect for analyzing the planet's heat signature and atmospheric properties. What's more, Proxima Centauri b completes an orb around its star every 11.2 Earth days, the same rate at which Webb orbits Earth, making it easier for scientists to monitor its daytime conditions. If the planet does have an atmosphere, the next step is identifying its components. Detecting elements like oxygen, water vapor, and methane could suggest the presence of life. To find these biomarkers, scientists must study the light passing through the planet's atmosphere, a difficult task. While JWST is optimized for detecting water vapor, carbon dioxide, and methane, it's not as effective at spotting free oxygen, which is a key indicator of life. However, it can detect ozone, another possible sign of a healthy atmosphere. As researchers continue analyzing Webb's data, the hunt for life beyond Earth presses on. Still, JWST can only deeply study the atmospheres of a handful of the nearest exoplanets. That's where next-generation ground-based telescopes like the extremely large telescope ELT, expected to be operational by 2028, come in. The ELT will offer much higher resolution views of exoplanet atmospheres, delivering more precise data on whether these worlds could support life. Looking ahead, scientists have big plans for future space telescopes. They're developing advanced technologies that block out starlight to better observe the dim light reflected by planets, kind of like shading your eyes to see more clearly. Since stars are far brighter than their planets, blocking their light is crucial to revealing the faint signals needed to study exoplanets. To solve this challenge, astronomers are turning to tools like coronagraphs, devices placed inside telescopes that block a star's light while allowing planet light through. By manipulating light waves, coronagraphs dramatically reduce stellar glare, revealing the faint glow of orbiting planets. Another groundbreaking innovation is the Star Shade, a massive, flower-shaped spacecraft that flies tens of thousands of kilometers away from a telescope. The Star Shade blocks starlight before it even reaches a telescope, allowing only the light from nearby planets to enter. This could be especially useful for observing planets in the habitable zone, where conditions may allow for liquid water and possibly life. These advanced technologies require astonishing precision. For instance, a star shade must be aligned with pinpoint accuracy, down to a fraction of a millimeter across vast distances. Plus, any new device must survive the rigors of space, operate with minimal energy, and be compact enough for launch. Despite the challenges, the potential payoff is enormous. By capturing detailed data on exoplanet atmospheres, scientists hope to identify biosignatures, chemical indicators of life, such as oxygen, methane, or water vapor in specific combinations. These findings could ultimately answer one of humanity's biggest questions. Are we alone in the universe? Rephrased version. Modern telescopes can now use advanced adaptive optics to correct distortions caused by Earth's atmosphere or the telescope's own movements, resulting in crystal clear images, even when blocking out starlight. This innovation could soon allow scientists not only to detect exoplanets, but also to map their surfaces and analyze their weather patterns. The next generation of space telescopes represents a major leap forward in our quest to answer one of humanity's greatest questions. Are we alone? With improved capabilities to observe distant worlds in greater detail, we're inching closer to the truth. Space exploration is progressing rapidly. As astronomers investigate far-off exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. Each new observation brings us closer to uncovering signs of life beyond Earth. Take Proxima Centauri b, for example. This could be just the beginning of a game-changing chapter in the search for extraterrestrial life. Proxima Centauri, our closest stellar neighbor, has been the subject of study for years. The idea of finding real evidence of life there, such as artificial lights or signs of civilization, once seemed like a distant dream. But recent observations by the Webb telescope hint at such possibilities, igniting hope that we may one day communicate with intelligent life. This discovery has sparked excitement among scientists and the public alike, inspiring a new generation to look to the stars. The Webb telescope isn't just searching for lights. It's analyzing planetary atmospheres, looking for chemicals like methane and carbon dioxide that could be potential biosignatures, clues that a planet might support life. The potential detection of artificial lights on Proxima Centauri b isn't just a thrilling scientific moment. It's a turning point. For decades, we've looked up at the sky and wondered if someone might be looking back. Now, with the Webb telescope's unmatched sensitivity, we're seeing hints that could one day turn speculation into evidence. The idea that we might be observing patterns of light that resemble those from intelligent civilizations moves the idea of alien life from the realm of science fiction to serious, testable science. Even if these lights turn out to have natural causes, the tools and methods we developed to search for them are propelling us into a golden age of astronomy. Upcoming instruments like the extremely large telescope JWST, along with future space telescopes equipped with coronagraphs and star shades, will sharpen our ability to study exoplanets in unprecedented detail. These technologies will help us measure atmospheric compositions and detect molecules strongly associated with life. This level of precision brings us closer than ever to answering one of the most profound questions in human history. With every new dataset, improved technique, and technological advancement, the search for life beyond Earth becomes more focused and more promising. Even if we're still years away from making contact, the fact that we can now detect potential signs of life across light years is a testament to human curiosity and ingenuity. Whether the lights on Proxima Centauri turn out to be artificial or simply rare natural phenomena, the journey to uncover the truth will drive scientific progress in unimaginable ways. The universe is vast, but thanks to these breakthroughs, it's beginning to feel just a little less lonely